Welcome to homework.
We're told that the starter motor of a car is turning too slowly, and the mechanic has to decide whether to replace the motor, the cable, or the battery. So the manual says that the 12-volt battery should have no more than a 0.02 ohm internal resistance. The motor should have no more than a zero point 0.2 ohm resistance, and the cable no more than a 0.04 ohm resistance. The mechanic turns on the motor and measures 11.4 volts across the battery, 3 volts across the cable, and a current of 50 amps. And we got to figure out, given that information, which part is likely defective. So we have this power supply here, and this would be the ideal power supply, and then it has some internal resistance. So this is kind of the battery here, and then we have some resistance in the motor, and some resistance in the cables. Now, this resistance in the motor is actually going to be just the back EMF on the motor is just assuming that the motor isn't spinning. So this is just the resistance of the coils in the motor. So somehow we would actually have to. We don't really want to start the motor here, and that's kind of why I've never heard this being done. But you'd have to kind of block the motor from turning to measure the resistance through the windings, and it would be better just to take a multimeter and measure the resistance directly through the windings instead of trying to turn the battery on and keep the motor from from spinning. Anyway, that being said, we have a 12-volt battery. The voltage drop between these 2 points is 11.4 volts. Across the cabling is 3 volts, and then there's 50 amps. So the voltage from A to B, or B to A, is V minus I times the internal resistance. And that we measured as 11.4 volts. That means that I times the internal resistance of the battery is 0.6 volts, so RV is 0.012 ohms, which checks out as being smaller than the maximum we would expect for internal resistance in the battery. Now we can easily measure internal resistance in the cable. We know we have a voltage drop across it of 3 volts, and we have 50 ohms, and that we get a resistance of 0.06 ohms, which is greater than the maximum that it should be. So basically it appears that our cable is bad. At least our cable is bad. So then we can figure out what the resistance is in the motor by saying that, okay, we have 50 amps. So that's a total current going through here. And we have all of these resistors are in series, basically where everything's lined up, in series. Although, the resistance of the cable, some of it may be over here, some of it may be over here. We can kind of lump it all together. And so in this equation, the only thing we don't know is the resistance of the motor. And so we can solve for that. And that is V over I minus RV minus RC. And that is 0.168 ohms. And that is within spec, right? Yeah, it should be no more than 0.2. So that's within spec too. So it looks like the motor's good. So it looks like basically maybe there's a bad connection with the cable, or internally something is, rusted or something at the cable. But usually it's probably a connection. There's probably a connection. The terminal from the battery is probably corroded and not making good contact. So it'd probably be a good idea to clean the cable off, or at least replace it.